Hello guys, so we are continuing with this question paper. We are now in question number 9 and yeah, we're very close from finishing. We're very close from finishing. Now there's something important that I want us to do, and also if you took the course that I've sent for what is this for differential calculus, there's something that was displayed into this question, and this question paper has been one hell of a good question paper. So now I want to show you something. I want to show you something before we start answering these amazing questions that have been set up for us. Now look, if you have a function like this, and they say this function is a derivative from the original function, you need to know a couple of things. The first thing that you need to know is the value of a is obviously increasing. So I just want to draw something. Okay, let me just draw something like this. I just want to draw something. And this is f. So look at this. This is f. Remember that if this is a cubic function, if you derive a cubic function, what do you get? You get a quadratic expression. Let me give you an example. If you are having f at x equals to x cubed plus 6x squared plus 9x plus 10, if you derive this, you actually get 3x squared plus 12x plus 9. So a derivative of a cubic function, you're gonna get a quadratic function. So this is a cubic function, and when you derive it, you're gonna get what? You're gonna get a quadratic expression. So there are some things that you need to know before we answer this question, because I don't want you to look like a when answering this question. Now you start to realize that the turning point, it is the x-intercept. So the turning point is the x-intercept, as well as the point of inflection, it is the turning point of the quadratic sequence. So I want you to know this, okay? So the turning point of the original function, it is the x-intercept of the quadratic function. And the point of inflection, it is going to be the turning point of the quadratic one. Now, when you have this question, you need to draw the same thing. And by the way, what do you realize? You realize that in this function, because of how it is drawn, the value of a is greater than 0. What about if the value of a is less than 0? So if the value of a is less than 0, what you want to realize is the function would be sad, right? And if the function is sad, it means that even this one, it has to start by decreasing and then increasing. So we're gonna get the same thing. You're gonna find that the x is the turning point, the x is the turning point, the point of inflection is the blah blah blah. It's just that I drew something that's not in scale, but in scale, that's how it should be. Now let's look at this question. What do we realize? We realize that the question said the sketch below is the graph of a derivative. The derivative of f at x, yeah, it is. So what do we realize? We realize that it has a negative value of a. So you need to draw this. You need to say, okay, it's gonna decrease and then it's gonna, okay. So we're just measuring it. So you realize we're gonna have something like this, this, and this. So you need to draw this without anyone telling you. The moment they say this function is coming from a derivative, you need to draw this. You need to draw this and tell yourself and be like, okay, the turning point of this one is going to be, just do this in your exam. Do this in your exam. You will thank me when you come back and say, Marvel, it helped me a lot. And the turning point of this one is going to be the point of inflection. Bam, you're done. And then now you start answering your question. You see, this question paper is a very good, revision. I love it. I loved it. Now they say, write down the coordinates of A. How do you write the coordinates of A? You realize that A is actually on the quadratic expression and it is the value of Y. So they say, write down the coordinates of A. So they do not expect you to calculate anything. So you realize you are given f at x that equals to minus 2x cubed minus 3x squared plus 12x plus 20. What is the value of A? So the value of A is obviously 12, isn't it? Because like when you derive this, you're gonna realize the value of C is 12. So let's just derive it. If you derive this, you're gonna have minus 6x squared minus 6x plus 12. Can you see it? So the value of C is obviously 12. That means that the value of A, it's going to be an amazing 12. They didn't say calculate, they say write down. So that's what we have done. And now they say find the coordinates of B and C. So here are the coordinates of B and the coordinates of C. So when we calculate the coordinates of B and C, we realize these are just the x-intercepts of the quadratic expression. So that's what we're going to do. We're going to use the quadratic expression to find this. Okay. We're going to find the quadratic expression to find this, and the answer that we get is x is going to be minus 2, and then we also find that x is going to be 1. So obviously b, it's going to be minus 2, and this one is going to be 1. So you immediately know that even the turning points, the value of x is going to be at minus 2, and it's also going to be at 1. Isn't it? Yeah. Now, they ask you, look at this, guys. For which values of x will f at x be increasing? Look at this. They are not saying f prime of x. They are saying the original f at x. They say, for which values of x will f at x be increasing? Obviously, if you did not draw this red graph, what are you going to do? But because you drew this red graph, you can see that this red graph is increasing from x equals to minus 2 until x equals to 1. So you're gonna say they are actually increasing from x equals to minus 2 until x equals to 1. You can see it. From x equals to minus 2, it is increasing until x equals to 1. And it is much more visible if you have drew the red graph. Now they say, determine the y coordinates of the point of inflection of f at x. So now, do you want you to calculate the point, the y coordinates, not the x coordinates? They just want the y coordinates of the point of inflection of f at x. And you know that the point of inflection, it is just the turning point of the quadratic expression. And you know how to find the turning point. I'm not going to find it. So just find the turning point. At that turning point, it's the point of inflection of the original function of f at x. And now, ladies and gentlemen, I'm going to see you on question number 10. You know what? Question 10 wasn't that long, by the way. Let me see. Question 10 wasn't that long. So I want you to do question 10 as part of your amazing homework. And I'm going to see you on question 10 just right after this video.